everyone. Let's talk about today's respiratory HQ challenge, and it has to do with humidity and humidity deficit, which is always a little bit confusing when you first start out with it. So if you want to know more than what this question asks, I urge you to go to my YouTube channel, Respiratory HQ, and I've got a little video on there talking about body humidity and humidity deficit, so maybe that'll help you out a little bit. Or you can always go to my website, respiratoryhq.com. I've got free instructional videos there. But let's just talk about this. The RCP is delivering 2 liters per minute via nasal cannula with a bubble humidifier, all right? The absolute humidity is 10 milligrams per liter. So what the absolute humidity is how much humidity that bubble humidifier is giving, okay? So we're providing 10 milligrams per liter. But the question is, what is the humidity deficit? Okay, let's just make sure we understand what this is with a really bad picture. But basically, here is your trachea, the carina. It branches off into the main stem bronchi, and then the right and the left lung, okay? So about 5 centimeters below the carina is a place in the airway called the isothermic saturation boundary. And what that is just the point when a person's breathing normally, when all the air that we inspire is 100% saturated with water vapor, and it's warmed up to body temperature. So at the level of the ISB in normal circumstances, this is going to be body temperature, 37 degrees Celsius, 98.6, okay, Fahrenheit. But also right here is when, because it is body temperature, the air that's been inspired is fully saturated with water. And when it's fully saturated with water, that amount of water is 44 milligrams per liter, all right? And that 44 milligrams per liter exerts a pressure of 47 millimeters of mercury. This is where you get that water vapor pressure when you're doing the alveolar air equation, okay? So basically, when we come back to this question, what we're saying is we got a nasal cannula on somebody and it is delivering 10 milligrams per liter of water vapor. The body needs 44, that's what it's striving for, so the humidity deficit is what we are not delivering, what the body's going to have to come up with on its own. So if we're delivering 10 and the body needs 44, quite simply the deficit, what we're not delivering, or what the body has to make up for, is 34 milligrams per liter. Hope this helps.